Hello. In this video, I will do an IBEW 2. I will do an IBEW introductory test regarding exponents, and we'll do two of them. So yeah, let's talk about exponents. So before we do this problem, I want to go over some of the rules for regarding exponents. So if you have a piece of paper or if you have a notebook, go ahead and write this down. So what are the rules of exponents? So one of them is if you're multiplying with the same base, so it doesn't matter what letter it is, as long as it's the same base. So it could be X, Y, Z, etc. So let's start with X's. So when you're multiplying with the same base, for example, if you have X3 times X2, when you're multiplying, you're really adding. So this would be X5. Let's see, raising. So don't, a lot of people get this confused. So when you raise, you really multiply. So for example, if you have X3 raised to the second power, when you raise, you multiply, so that's x6, right? 3 times 2 is 6. Third one is when you divide. So let's say you had x5 divided by x3. You're really subtracting the exponent, so it's going to be x to the 5 minus 3, which is x squared. Okay. Next one is, what is the other? Oh, negative power. So sometimes they want only positive powers. So for example, if you have x to the negative 3, as a positive power, you would write this as a 1 on the numerator and then x to the positive 3 on the bottom, right? And lastly, this is also important. If your negative exponent is on the bottom, so for example, if you have 1 over x to the negative 3, so if your negative exponent is on the denominator, it magically becomes positive. Um, so this becomes x to the third. So, like, if you're really curious why that is, one, it's like if you simplify 1 over x to the cubed, x to the negative 3 is the same thing as 1 over x cubed, right? And then you have a complex fraction. So it's really 1 divided by 1 over x cubed. And remember, when you have division, you cross multiply. So that's going to be x cubed over 1. Okay. So go ahead and write these 5 rules because we're going to probably use it. Now, if you still need help with exponents, you can go check under the supplementary videos and Uh, I should have a video regarding exponents. I don't think that will be necessary. Okay, got it? Okay, let's move on. So we know your exponent rules. Let's just move on. So question one says, what is 1/2 all raised to the third? So it's really important that they put parentheses. So did you know you could express this several ways? You can rewrite 1/2 to the third as the same thing as 1/2 times 1/2 times 1/2. And if you recall, when you multiply fractions, you multiply across. So 1 times 1 is 1. And what's 2 times 2 times 2? Well, 2 times 2 is 4. 4 times 2 is 8. Okay, so it's 1/8. Or what you could have done is you raise exponents. Now, 1 over 2 don't have the inner, this doesn't have an exponent, so or it has an invisible one, right? So remember when the that we were rule 2, when you raise, you multiply the exponents. So this is like saying what's 1 times 3? 3. And then the new exponent for 2. So this 2 has an invisible exponent 1. So what's 1 times 3? 3. And then you know what is 1 to the third power? 1. And then what's 2 to the third? That's like saying 2 times 2 times 2. That's 8. Okay, so that's how you get 1/8. Okay, not too bad, right? Okay, let's move on to the next. Okay, let me clear. Question 2 says, evaluate negative 2 to the third, example, negative 2 to the power of negative, it's okay. So this is kind of important. There's parentheses. So um this is not a bad one. So this is just saying negative 2 to the positive 3 is the same thing as parentheses negative 2 times negative 2 times negative 2. So you just have to do this out. What's negative 2 times negative 2? 4. And what's 4 times negative 2? Negative 8. Well, that's your answer. Okay, next one. Question 3. Simplify 4 to the negative 2 times 4 to the fifth. Okay, so notice that they were the same base. That's good. Um, if they're not, you kind of have to like manipulate it to make it as a same base, but this would be rule 1 when you're multiplying with the same base. Our same base is 4. You add the exponent. So this is like saying negative 2 plus 5, which is the same thing as what's negative 2 plus 5? Positive 3. And if you look at our chance answers, there's no 4 to the thirds. That's why you have to simplify it. So what's 4? So you can't use a calculator. So what's 4 times 4 times 4? 4 times 4 is 16. And then 16 times 4 is, without a calculator, 6 times 4 is 24. Carry the 2. 4 times 1 is 4 plus 2 is 64. And the answer is 64. Okay. Okay, next one. The next one says question 4, simplify 7/5 over 7 squared. So the good news is they're both in the common base of 7. So this would be dividing with the same base, you technically subtract. So it's really, you subtract the exponents of 5 minus 2 is 3. And 7 to the third is the same thing as 7 times 7 times 7. Without a calculator, 7 times 7 is 49. And then 49 times 7. 9 times 7 is 63, carry the 6. 7 times 4 is 7 times 4 is 28, plus 6 is 28. 29, 30, 31, 32, 33, 34. So it's 343. Okay, so yeah, you can do this without calculator because I'm not doing it, so that's good. Okay, let's move on to this one. We have 3 square. Okay, so what I would, okay, so yeah, this is kind of like a mess. 3 square times 3 to the negative 4 over 3 to the negative 1. Do not divide yet. What I would do is simplify the numerator, simplify the denominator if you can, and then you may divide. So yeah, let's look at our numerator. What's 3 squared times 3 to the negative 4? That's technically multiplying, so you're adding. So what's 2 plus negative 4? Negative 2. Okay. Divided by 3 to the negative 1. Okay, so now, see, I just simplified the numerator and then the denominator says. So when you're dividing with the same base, you subtract the exponent. So be careful. It's going to be 3, and then it's going to be negative 2 minus this exponent, this power, negative 1. So it's minus a minus 1. And what happens when you have two negatives? It becomes a positive. So what's negative 2 plus 1? Negative 1. Do you see our answer? No, because we got to put it as a positive power. So how do I write 3 to the negative 1 as a positive power? It would be 1 over 3. Next one. Question two. Simplify 2 to the third times 3 to the third. Uh-oh. What do you see? Okay, so it's 2/3, 2 to the third times 3 to the third. Yeah, we have a problem. What's the problem? They're not in the same base. This is a base of 2. This is a base of 3. Is there any way we could put it in a common base? No, we can't. So what you're going to have to do is just multiply it out. So what's 2 to the third? That's 2 times 2 times 2, which is 4 times 2. 4. 2 times 2 is 4 times by 2. That's 8. And then what's 3 to the third? That's 3 times 3 times 3. 3 times 3 is 9 times it by 3 is 27. What's 8 times 27 without a calculator? So it'd be 27 times 8. 8 times 7 is 56. 8 times 2 is 16, plus 5 is 16, 17, 18, 19, 20, 21. So I get 216. Okay. Okay, let's move on to question 7. Simplify 4 squared divided by 1/5. Yikes. There's no way we could put, they're not in a common base. There's no way we could put it in a common base. There's no way, between 5 and 4, there's no way you can do that. So what you could do is just simplify it. 4 squared is 16 divided by 1 over 5 squared. 5 squared is 25. Then what you could do is you can either cross multiply or you can flip this, change this divide sign to multiplication and then flip this 1/25. So that'd be 25 over 1. Excuse me. And then all you got to do is multiply 16 by 25 and then 1 over 1. So what is 16 times 25? So you're gonna do the without a calculator. It would be 6 times 5 is 30. Carry the 3. 6 times 2 is 12, plus 3, 12, 13, 14, 15. Placeholder, and then 1 times 5 is 5, and then 2 times 1 is 2. And then 5 plus 5 is 10. Carry the 1. 2 plus 1 is 3, plus 1 is 4. And then, so it's going to be 400 over 1, which you cannot simplify, right? So it's just 400. Okay, question 8. How much do we have? Oh, we have 11. 4 square plus 2 square. Okay, unfortunately, this is not multiplying, dividing, or subtracting. So even if we put it in a common base, there's nothing we can do. So you're just gonna have to, yeah, we don't have any rules for addition, right? It was either multiplying, dividing, raising, or dividing, right? There's no way we could, yeah, we can, there's no way. So you're just gonna have to simplify this. What's 4 square? 16 plus, what's 2 square? 4. What's 16 plus 4? That's 6, 7, 8, 9, 10. Carry the 1, that's 20. Good. Evaluate 5/3 minus 2/3. As you can see, there's no way we could put it in a common base. 5 and 2, and it doesn't matter because there's no rule for subtraction. So we just gotta figure this out. What's 5 to the third? Honestly, I'm not sure. 5 times 5 times 5. 5 times 5 is 25. I think it's 125. Yes, 125. So it's 125 minus 2 to the third. What's 2 to the third? Times 2. 2 times 2 times 2, that's 4 times 2, that's 8. So what's 125 minus 8? It would be 9, 10, 9, 10, 11, 12, 13, 14, 15. It's 5, 6, 7. Carry the 1. That's 1. Um, and then 1. That would be 117. Right? Double check. Yes, 117. Okay, let's do this one. So question 10 says, what's 6 squared times 6 to the third divided by 6 to the fourth? The good news is they're all in the base of 6, so we can simplify this using our rules. So what I would do is do not divide everything by 6 to the fourth. Instead, simplify the numerator. So what's 6 squared times 6 to the 3? Well, when you're multiplying with the same base, you're adding. So 2 plus 3 is 5 over 6 to the fourth. Okay. Now, when you have the same base, you subtract. So it's going to be 6 to the 5 minus 4. And that would be 5 minus 4 is 1. So it's 6 to the 1, which is 6. Okay. Question 11, you have 1 over 10 to the negative 2. So remember the rules that we said that if your exponent is negative on the denominator, it somehow magically becomes 10 to the positive 2. And then 10 to the positive 2 is 100. Okay. Now, why is that? If you want to do the actual theory about it or the work, this 1 over 10 to the negative 2 is the same thing as 1 over. And how do I write 10 to the negative 2 as a positive power? It would be 1 over 10 squared. Now you have a complex fraction. This is your numerator, this is your denominator. So if you want, you can rewrite this as 1 divided by 1 over 10 squared, right? And then what you would do is like you can cross multiply, right? Or change this divide sign to multiplication and flip it. So 1 times 10 square is 10 square. 1 over 1 is 1. 10 square is 100. So third one. Okay, that was that one. Now let's do something with letters. So let's go back to our summary. Hold on. Oops, not this one. Let's see. Oh yeah, this one. So now we're dealing with variables. So let's begin. Okay. So question 1 says, what is x3 times x to the 4th? The good news is they're both in the same base. They don't have to, as yeah, like we said, same base could be a same letter, same number. It doesn't really matter, but we know that this is the same base, x, and when you're multiplying with the same base, you technically add the powers, right? So 3 plus 4. So that's 3 plus 4 is 5, 6, 7. So that is this one. Okay. Question 2. What is a7 divided by a cubed? Well, when you're dividing with the same base, you technically subtract. So this is going to be 7 minus 3, and then 7 minus 3 is 4. Question 3. What's x2 divided by x5? You technically subtract, right? So you're dividing with the same base, so you subtract. So it's going to be 2 minus 5, and then 2 minus 5 is negative 3, right? 2 minus 5 is negative 3. And then how do I write that as a positive power? It's just 1 over x3. And I don't see your answer because they just left it as negative power. So, yep, I guess it's this one. Correct. Okay, good. So maybe they don't want it all positive. Okay. Let's do question 4. So question 4 says, we have y3 raised to the second power. So what is that? So remember the raising is when you multiply. So when you raise an exponent, you're multiplying. So it's going to be y, what's 3 times 2? 6. Yep, that's simple. Okay, let's move on to this one. Question 5 says simplify this. We have x squared times y cubed raised to the second power. So what I always tell my students is when you have something different letter and more than one stuff in the parentheses, always check if you can simplify the inner parentheses before you raise it to the power 2. So in the inner parentheses, we have x squared and y cubed. Can we simplify them? No, because they're different letters. If this was both y's or both x's, then yes, simplify that before you raise to the second power. Because they're different letters, we can't. So we'll just have to raise everything to the power 2. So start with the x. What's x squared raised to the power 2? So remember when we raise, you multiply. So 2 times 2 is 4. What about y? What's y cubed raised to the second power? That is going to be 3 times 2 is 6. Okay, so that is your answer. Last one. Okay, next one. So simplify x cubed times x to the negative 2. So the good news is they're both the same letters. So what happens when you're multiplying with the same base? You add the exponent. So what's 3 plus negative 2? That is 3 plus negative 2 is 1, and you can't go any further than that. So it's going to be this one. Next one, simplify x to the negative 3 divided by x to the negative 5. So the good news is they're both x's, so you can write it into one single x. And be careful with this one. So when you're dividing with this same base, you subtract. So it's really negative 3 minus a minus 5. And what happens when you have two minuses? It becomes a positive. So 5 minus 3 is 2. Okay, next one. Simplify x squared times y squared. They're different letters. There's nothing more we can do, right? X squared times y squared, they're different letters, so we can't combine them. So it is what it is. So another way of expressing this is that one. Whoops, incorrect. Oh, okay. Let's see what is this wrong? I guess technically you can. Oh, this is a tricky one. I think this is partially correct. I guess they want it like this because parentheses xy squared is the same thing as x squared y squared. So don't so be careful with this one. So even though I think this is partially right, um, they want it like this. Yeah, that is a yeah, if they had the problem like this on the test, that would suck. They should at least give you some points, but yeah, so this is the same thing as parentheses xy square. So the first one. Okay. Next one, question 9. We have parentheses AB raised to the negative 2. So did you know, first check in the inner parentheses, can we combine like terms? Can we simplify this? No, we can't because this is a letter, they're different letters, right? A and B. So we can't simplify the inner parentheses. So we'll just have to rewrite this as a positive power. So it's just the same thing as 1 over parentheses AB squared. And do you see our answer? Not yet. So this also could be expressed as what's AB raised to the second power? That's the same thing as A squared, B squared, right? So is it the first one? A to the negative 2 is 1 over A squared plus B to the negative 2 is 1 over B squared. No, they're not. They will not give you this. Is it the second one? A to the negative 2 is 1 over A squared times, because it's squished, B to the negative 2 is 1 over B squared, which is 1 over A squared, B squared. Oh man, that could be true. What about the third one? 1 over A squared. Oh my gosh, it's either this one or this one. What about the last one? No, wait. It would be 1 over A over B. No, that's never going to give you this. So what do you think? What would my gut say? So let me think. What do you think? I think it's this one. It could be this one. Let's just find out. Oh, it is. Okay, so 1 over x squared, a squared times b squared. 1 over a squared times b squared is the same thing as this. So that is kind of tricky because I would have picked this one too. This could be true. I guess it's that the keyword was simplify, so I guess they want it in the most simplified. I guess they didn't want negative powers, so that's why it's the third choice. Okay, how much? We have 15. So question 10. We have y6 times y to the negative 2 over y cubed. So what I would do is simplify they're all in the base of y. That's good, right? They're all in the base of y. So what I would do is simplify the numerator and then do the denominator. So what is y6 times y to the negative 2? That is, remember when you're multiplying, you're adding. So 6 plus negative 2 or 6 minus 2 is 4. And then you have y to the 3. What's y to the 4th divided by y to the 3? So when you're dividing with the same basic technique, subtract. So 4 minus 3 is y to the 1. Okay, so which one is y to the 1? It's the third one, right? Y to the negative 1, that's not it. Y to the 5th, no. You don't see an exponent 1. Why? Because you don't need it. If it's just by itself, did you know y is the same thing as y to the 1? So that one. Okay, let's do question 11. What is q squared divided by q to the negative 3? So the good news is they're both in a base of q. So all you got to do is subtract the exponents, right? So you subtract the exponent. So it's 2 minus a minus 3. And we know that two negatives becomes a positive. So that's q to the 5. So third one. Okay, question 12. X squared plus x cubed. Um, there's no way. Okay, even though they have the same base of x, there's nothing we can do. We're not multiplying, we're not dividing, we're not raising, right? There's no rule for addition. So you just have to, yeah, this is not multiplication. So you just, I think it is what it is. You can't go any further. So yeah. Um, now if it were the same exponent, so for example, if it was x cubed plus x cubed, you can combine them. You just add the coefficient. So this has a coefficient 1, 1, so that would be 2x cubed. But unfortunately, there are different bases. This is a base of 3. I mean, this is a power of 3. This is a power 2. You can't do much. It has to be the first one because you can't simplify it any further. Simplify. So let's see. We have 13. We have a cubed minus b cubed. Unfortunately, there's different letters. They may have the same exponents, but they're different letters, so we can't do much. Um, it is what it is. So be careful. Which one do you think it is? Is it the first one? Maybe. Is it the second one? Maybe. Is it the third one? Definitely no. Is it the last one? Definitely no, right? They're different exponents. This one is division. There's no way we're going to, minus does not mean divide, right? I mean, if you divide, you're subtract the exponents, but it's not the other way around. It's either the first one or the second one. What do you think? I think it might be the first one. I don't think it's the second one because a minus b cubed, that is not the same thing as raising it to the a to the 3 and b to the cube. It's the same thing as this. A minus b cubed is the same thing as a minus b times a minus b times a minus b. And when you FOIL it out, there's no way it's going to turn out, there's no way it's going to turn into a cubed minus b cubed, right? It's like going to be an a squared. No, it's all one big mess. So it has to be the first one. So that can be a tricky one. Correct. Good. Okay, 14. We have 3x squared raised to the third power. So we have something inside the parentheses. So what I would always do is check if you can simplify the inner parentheses. So we have a 3. We have an x squared. Can we simplify the inner parentheses? No, because you have a constant and a variable. They don't mix. So let's just start raising everything to the third power. So a lot of students forget they don't raise the third 3. This is still part of your problem. So what's 3 raised to 3? This has an invisible power 1, so 1 times 3 is 3, so that's like 3 to the 3. And then what about the x? That's x squared raised to 3, that's x6. Put it all together, what's 3 times 3 to the third? 3 times 3 is 9, 9 times 3 is 27. You get x is 6. So this one. Let's do question 15. Simplify. We have a fourth b squared over a b fifth. So what I would do is yeah, so this one's a trick, kind of tricky, but it's doable. So on the numerator, when you're dealing with fraction, always see if you can simplify the numerator. So we have a fourth b squared. Can we simplify them? No, we can't. Why can't we? Because they're different letters, right? What about the bottom? Can we simplify these? No, we can't because they're also different letters. So what we'll do is let's divide the letters. So let's start with A. What's A fourth divided by A one? And then it's times B squared. So we can rewrite it like this, B squared divided by B5. So let's start with A fourth divided by A1. What's 4 minus 1? When you're dividing, you subtract the exponent. So what's 4 minus 1? 3. Times, because it's squished, that's why it's times. What's B squared divided by B5? Well, when you're dividing with the same exponent, you subtract. So 2 minus 5 is negative 3, not positive 3. So it's b to the negative 3. Now, do you see our answer? No, not yet, because we have to simplify it. So I think if you look at all our choices are all positive exponents. So we're going to simplify it. So start with a cubed, and then b to the negative 3 as a positive power, it's 1 over b3. And then FOIL this out. What's 1 times a cubed? A cubed, and then b cubed. So it's this one. Okay, that's your answer. Okay, that was the last one, question 15, so we can stop here. Okay, so yeah, that was exponents regarding the IBU exam.